Hey everyone. In Unit 1, there are many instances where you need to solve productivity problems. So it does some good coverage of it in the chapter materials, but I wanted to give you my view on it. I hope maybe it'll help you in solving this problem. So I'm just going to do two samples, a single factor productivity problem and a multi-factor productivity problem. So single factor, um, it's still output over input. Anytime we talk about productivity, it's going to be output divided by input. We're only going to use a single output on the bottom in this situation. So look at this problem. It comes right out of the textbook. Natalie Attire makes fashion garments. During a particular week, employees worked 360 hours to produce a batch of 132 garments. So I'm already starting to see my inputs and outputs. My input is this 360 labor hours. So the only thing I know is my labor productivity. We produce 132 garments, so that starts to tell me what the output is. Now here's the tricky part with output. We can use output just as a quantity in a productivity problem, and that's fine. But if we know the value of the output, then it's a lot more interesting, it's a lot more usable in a business context. And in this case, we do know the value of those 132 garments we produced. And it says 52 were seconds. That means they were flawed. Seconds are worth $90 each. So it's going to be 52 times 90. Now we also have another 80 that are perfect. So we're going to be able to sell those for our regular price of $200. So that's kind of what's going to go into this problem. And let me just break it out for you here. We'll just do the math together. So what is the output? We know the value of the output, so we're going to use the dollars. And we see it's 52 that are seconds. So it's 52 times $90. And then 80 are going to be top quality, so they're going to be $200. So we're going to do the math on both of those pieces and add them together, and that'll be the top of our equation, output over input, $20,680. Now our input, if we read the problem, there really is only a single input that's given us, and that's that we worked 360 hours. So our productivity, single factor, is going to be the value of the output, 20,680, divided by 360 hours. Now here's where people often get this wrong. We certainly can get the math in our calculator. We're going to get 5744, but realize that that's dollars, so it's whatever the unit of measure was on the top of the equation. So it's $57.44 per hour of labor. So that little slash in the division sign, that's per. So the top, we got 57.44 per 1 hour of labor. Now, I mentioned this in the lecture earlier this week. That number really doesn't have a whole lot of meaning. Productivity is a relative measure, so I need to use that number and compare it to something else. So if I have this data this week, and then I decide I'm going to train my people differently and show them how to be more efficient, then next week we measure productivity again to see if the productivity improves, if our training worked. Maybe I buy a new machine and I have one of the people using this new machine. I'll measure their productivity again and see if our productivity increases. So if I spend more money on equipment or on training or on lighting or on air conditioning, I should measure the productivity again and see if it had any impact on my productivity. So that's single factor. Let's take a look at a multi-factor. And the difference is we have information on more than one input. So rather than just knowing the labor hours, we know more. There's still only one real output. It might be seconds and first, so we might have to do a little multiplication, but still we're going to look at a single body of output that we have that week. So let's look at this problem out of the book. Max guitars, we'll take a look at something a little more interesting. Typically, I'm just reading it, the highlights here. Typically out of 100 guitars that they build production each month, only 80% are good enough to sell. The other 20% are scrapped. So now we know what our output is, 100 guitars, but only 80% of them are usable. So it's going to be 100 times 80%. And then it says, a little further down, each guitar sells for 250. Well, right away I'm starting to see what my value of output is. And then the rest of it's going to tell me about the value of our inputs for the bottom half of the equation. So what's the output? It's 100 times 80%. because even though we produced 100, 20 of them we're going to throw away. So we've got to reduce that. We only count usable output. And since we know the value of that output is $250, we'll just multiply it together. And now the top of our equation we know is going to be $20,000. Now, what's the input? That's where in this problem it's multi-factor, so it's a little messier, but not too big a deal. When we start reading there in the middle, it says, because some of the production process is automated, each guitar only requires 10 labor hours. So now I know my 10 labor hours. Each employee works an average of 160 hours. That's a trick for us. That has no meaning. I don't care how many hours people work, because I know it takes 10 hours to produce a guitar. And the next line says that each hour costs me $10. So the cost of my labor per guitar is $10 times 10 hours. Materials cost $40 per guitar, and overhead is $4,000. So let me show you what that looks like when we put it together. So even though only 80 of them are saleable, we actually built 100 guitars. It takes 10 hours per guitar, and we pay $10 each. So we multiply 100 times 10 times 10. Then we look at our materials cost. We built 100 guitars. Even though 20 of them got thrown away, we still built them. So the materials cost us $40 each, so it's 40 times the 100. And then overhead, for the accountants in the course, you'll recognize what that is. That's for all those other costs that it's hard to assign to a single unit of output. It's like lighting and attorney's fees and HR department and sales brochures and all those other things that we need to run our business. That's the $4,000. So if we add all those together, we get $18,000. Labor, materials, and overhead, multi-factor. What is the productivity? It's going to be the 20,000 divided by 18,000, which gives us a factor of $1.11 of output for every dollar of input. Again, maybe we want to change the process. Maybe we want to improve our quality so we don't have to throw away 80%. That'll increase the top number, what we call the numerator in the equation. Maybe we want to train people better. That might reduce the hours from 10 hours to 9 hours. Then we would calculate productivity all over again and see if we actually get more dollars of output for every dollar of input. So if we ran it again and it came out the answer was $2, whatever we did worked. Give it a try.